Hi, welcome back to 4.4 problems in two dimensions. This is our last example, example 4, and it actually won't take too long. In this example, we're just going to use the cosine law. So far, everything we've been doing has been sine law based, so this last example will just cover the sine law. It says the radar screen on an air traffic controller tower shows a Piper Cherokee 15 kilometers from the tower in a direction of 30 degrees east of north, and a Cessna Skyhawk 16 kilometers from the tower in a direction of 40 degrees east of north. At their closest approach to each other, if the two aircraft are less than 2 kilometers apart, the controller must file a report. Okay. Sketch a diagram showing the tower and the two aircraft. Label the given distances and angles. Okay, so I'm going to start with the tower down here. I'm going to call it T for tower. And then I noticed they're talking a lot about north and east and whatnot. So we're also going to draw a line up here showing north. Okay, and obviously this down here would be east. Okay. All right. Okay, so it says there's the Cherokee. That's 15 kilometers from the tower in a direction of 30 degrees east of north. So I want to draw the Piper Cherokee 15 kilometers from the tower in a direction 30 degrees east of north. So if this is north, I need to go 30 degrees east of north. So I'm going to rotate, I'm going to rotate this way 30 degrees. Okay, so I should have a line going this way. That line should be 15 kilometers long. So I'll go ahead and I'll do that first. I'll draw this in blue. So there's north, and I got to rotate exactly 30 degrees from north. And let's say this is about 15 kilometers here. I'm going to call that C. I'll just go label it Cherokee. I guess we already had C for Cessna, so Cherokee. And this is 15 kilometers. And we have an angle of 30 degrees. Okay. The Skyhawk, that is right here. And the Skyhawk, it says it's 16 kilometers from the tower in a direction 40 degrees east of north. So from the north, I got to rotate 40 degrees now, a little bit past the other one. And it's also a little bit longer at 16 instead of 15, like the other one. Okay, so this is going to be the Skyhawk. Okay, this is 16 kilometers. And that angle is 40 degrees. So it says if these two aircrafts get 2 kilometers or less, like apart from each other, then they need to file a report. So most likely we're going to be looking for this distance in here. Okay, so there's our diagram. Everything's labeled with all their angles and distances. So that's part A. Part B, from the tower, what is the angle separating the aircraft? So they want to know what's the angle in here. That's actually pretty easy. Okay, the big one is 40, the small one is 30, so just subtract the two. We can figure out that those are 10. Okay, so 40 minus 30 equals 10 degrees. So they're 10 degrees apart. Okay, part C. Is it necessary to consider the ambiguous case justify your answer? Well, this is a angle side triangle because the angle's in between the two sides that are given. So therefore, no, we don't need to consider the ambiguous case. Only if it was side angle. Okay, lastly, part D. Will the controller need to file a report? So we're looking, for this distance right in between. So I'm given this side length, and the angle in between. Whenever you have side, angle, side, you should always use cosine law, okay? So when you have two side lengths and the angle in between, kind of like a sandwich, always think using cosine law. Okay, cosine law basically says it's going to look like this. So I haven't really labeled any of the vertices or nothing, but this is our cosine law. I'll write out the general formula. A squared equals b squared plus c squared minus 2 times b sine c times cos of the angle in between the two sides, cos angle A. Remember, these always pair up with each other as opposites. Okay. All right, so we're looking for this side here. So that's going to be my A. The angle A is going to be 10. That's what I'm going to use in here. My other two sides are the B and C, basically. So, okay, so I'm going to call this, basically just going to call this A to make sure that this, actually I'll call it something else. I'm just going to call it X. Okay, we're looking for X, and we want to make sure that X is less than 2, so they don't have to file a report. So X squared is going to equal my other two sides. It doesn't matter which one you put where. It works out to be the same. And then the angle in between, which is 10. Okay, put that all in your calculator. So we'll do 15 squared plus 16 squared minus 2 times 15 times 16 times cos of the angle in between 10. Okay, that's X squared. We're going to have to square root that. And it looks like we might be filing a report. So we'll take the square root of 8.29. And we got 2.87. I'm going to say it's approximately 2.9, okay, which will actually end up being kilometers. So 2.9 is greater than 2. Therefore, therefore, they don't need to file a report, right? Therefore, they don't need to file a report. Okay, if they would have been any closer than 2, they would have needed to, okay? All right, so that is it for 4.4. Hopefully you found these videos helpful. I will see you guys in the next lesson.